Hi everyone, welcome back to my YouTube channel Tech Data Engineer. So in this video we will see one of the most important DSA techniques, okay, which is basically asked in most of the product based company, okay, that is sliding window techniques, okay. So I have appeared for most of the product based company and I have seen the questions arises from this topic, okay. So sliding window techniques, okay, so they are asking question related to that, and even they are asking some I can say real-time examples also. So how we are using the sliding window technique in this scenario and all. Okay. So first we will understand what is sliding window techniques, and then we will understand some real-time scenario also. Okay. So so let us understand the sliding window technique. Okay, so sliding window technique basically it's like a pattern used to process like server arrays, server strings, or streams of data efficiently. Okay, so basically mostly it is used in case of streaming systems like Apache Spark, Apache Kafka, and Apache Flink. Okay, so that basically internally uses the window-based processing. So here we are using in case of Apache Spark. Okay, first we are using Apache Apache Spark. How we are using, I'll explain. Apache Spark, then Apache Kafka, and then we are using in Flink also. Okay, okay. So we are using in these places sliding window technique basically. So before understanding, first understand what is sliding window. Okay, so what is sliding window? SW, sliding window. So sliding window is a technique. It is a technique. I'll write a definition. It is a technique where we maintain. It is a technique where we maintain a subset of element. Subset of element that is called basically window. Okay, window that moves across data. That moves across data. Okay, so what is sliding window? Sliding window. So sliding window is a technique where we maintain a subset of element that moves across data. That is called sliding window. So let us understand a scenario. Okay, let us take an example of array. Okay, so let us take a example. Okay, so take a array with element 2, 1, 5, 1, 3, and 2. This is basically this is basically a array array of element. Okay, so how we are using the, and suppose we have window size is 3. Okay, window size is 3. So how we are creating, so what are the possible window we have? So one possible window is like a 215. I'll take it here, like it is a subset also. One possible window will be if I'll this is our original array of element, right? And if I wanted to take a windows of size 3, how many window we can create? One is 2 1 5. Other we can create like a 1 5 1. Then we have 5 1 3. Then we can create like a 1 3 2. So these are the possible window we can create from this original array. Okay, this is the possible window or possible sub array we can say. So the window slides forward one step at a time. Okay, so in this scenario, if you'll see, so first window would be of size 3, so it is like a 215. Then other would be of window size 151, and then other would be the size of 513. Okay, so here there is a increment of one element. Okay, that is the window we are incrementing. Okay, so that is the logic behind sliding window protocol. Okay, so this we understand, this is the sliding window. So then we need to understand why sliding window is needed. Okay, so why sliding window is needed? Why sliding window is needed? why sliding window is needed. Okay, so so if we don't have sliding window, okay, so what we have to do, if there is if there is an array of element, so we need to check each sub array. Okay, so suppose there are element like a 3 1 2, so how many sub array, like it's like 3 1 2, then 3 1 combination, then 1 2 combination, then 3 1 2. So these are the possible number of substring we have. Okay, these are the possible number of substring, and based on these brute force techniques, we need to analyze each subarray to solve any problem related to sliding window. Okay, so we if without sliding window, we need to check the every possible subarray or substring from that complete element. So if we are solving by using the brute force, so we have the time complexity of big O of n multiply k. Why? Because k is the size and n is the number of element. Okay. So it is big O of n into multiply k. Okay. But if you are using the sliding window technique, okay, if you are using the sliding window, so we are reducing the time complexity from n into k to order of n. Okay, big O of n. Okay, so this is the critical when processing millions of record in data pipeline. So whenever you are designing the data pipelines, this is very critical. The time complexity is very critical when you are designing and when you are handling the millions of record in data pipelines. Okay, so let us see a classical example. So in sliding window, we see a classical example, that is find the maximum, uh, find the maximum sum of a subarray of size k. Okay, so the our original array is like 2 1 5 1 3 and 2. Okay, and there is a sub array of size 3. So we need to choose a sub array of size 3, and how many possible subarrays, and we need to find out the maximum sum. Okay, so first if we'll analyze here brute force way, so how much we have? 2 1 5. Okay, what is the sum? 5 to 7 1 8. Then we have 1 5 1, it is like 7. Then we have 5 1 and 3, what is it is 9. And then we have the 1 3 and 2. So these are the possible subarray of size 1 3 2 6 and 3 to 5 and 1 6. Okay, so in if you compare all the subarray sum, so the maximum sum is 9, and that we have to find. So we have to find the maximum sum of a subarray of size k. Okay, so if we are solving this by using the brute force, so brute force method, you will come up with something like a complexity of order of n into k. Why? We have, because you have to run two loop. One is ranging from array of element, okay, and then again you need to sorry, you need to run another loop which is basically iterating the element. So your time complexity would be n into k. Okay, so we are not going to see the solution here, brute force solution, but we can consider here our time complexity would be order of n into k. Okay, so how we will solve this problem by using the sliding window protocol, sliding window techniques, because this brute force is not as scalable for large data sets. Okay, so how we will solve? So there are some method. So we will see some optimized solution. Okay, we will see we will see some optimized solution. So instead of recomputing each window, what we have to first, we have to calculate first window sum. Okay, what we have to do, we have to calculate the first window sum. Then what we have to do, we have to slide the window. We have to slide the window. Okay, I'm writing the steps. Okay, then what we have to do? Third, we have to do, we have to sliding the window. Then we have to add the new element. Add new element and remove old element. Fourth, remove old element. Okay, element. Okay, so how we are doing? Suppose we have the element like 2, 1, 5, 1, 3 and 2. Okay, so what we have to do, if we are taking a window of size this one, first we will calculate the sum of this one. Then what next step, what we will do, we will remove 2, we will add 1. Okay, so we will take this element, add it, and we will remove 2. Okay, then what we will do next, we will take this element 5 on 3 and we will remove. Okay, so this way basically we will do it here. Okay, this way basically we will do it. We will remove the previous element, we will add the next element, and we will create the sum, and we are sliding the window of size 3. Okay, so this way we will do. Now coming to the implementation, so basically I'll use Python. So how we will do it, so if you are comfortable with like this one normal loop and all, so you can solve it. So I'll take a same example like array. It is like a 2, 1, 5, 1, 3 and 2. Okay, then we are taking a size k equals to 3. K equals to 3. Okay, now window sum would be window under underscore sum would be. So what would be the sum, initial sum? Initial sum, how we are running the loop? We are running the loop like first window. K would be 3. So like 2, 1, 5. That would be the first sum. Okay. Then what would be the maximum sum? Maximum underscore sum equals to window sum. So initial we have whatever the window sum, that would be the initial sum. Okay, that would be the maximum sum. Then what we will do? We will run a loop like for I in range. What range we will take? We will take a range from this element like a k to length of array. Okay, alien length of array. Okay, so this we will run the loop from 3 to this one, because already we are considering this element. So next what we have to do, we are taking this window, then we are taking this window, then we are taking final this window, and in all that we will take the maximum sum. Okay, then so we are running the loop here. Okay, then what we will do? Uh, Okay. Then we are again window sum equals to window window underscore sum equals to window underscore sum plus what we are doing, we are adding the element. Okay, so I told you we are adding the next element and removing the previous element, plus array of I minus array of I minus k. Okay, then we are doing like a maximum sum equals to maximum of, we are taking maximum of maximum sum comma window sum. So comma window underscore sum. Okay, and then we are printing the print maximum underscore sum. Okay, so this way we are solving the sliding window. So when we are getting the output as a 9 and time complexity, because we are running the single loop, so time complexity order of n. Okay, so n time we are running, so order of n would be the worst case time complexity. Okay, so yeah, this way we will solve. Okay, and space complexity would be order of n. So we have already seen the sliding window visualizations. So, and in that, so in sliding window, that is the fixed sliding. So other we have in sliding window also we have the variable size. Okay, variable size sliding window. Okay, variable size sliding window. Then so variable size sliding window is something like a longest substring without repeating character. If this types of problem will come like longest substring without without repeating character. Okay, so if like something like a b c, then A, B, C, B, B. Something like if this element is there and you have to find the longest substring without repeating character. Okay. So this is called, this types of problem is called variable size. And then we have the time based also. So there are three types of sliding window. One is the fixed window, one is the variable window, and that is, third is the, one is the fixed, second is the variable, and third is the time based. Okay. Time based window. Time based window. Okay. So in variable window, we have seen longest substring problem that's come under. And what is time based window? Time based window is like, suppose instead of element, the window is based on time, right? So we have to suppose we have to do like last 5 minute data, or you are so if you talk about some data engineering use case, so I'll talk about the real time fraud. Okay, real time fraud detection. If you'll talk about real time fraud, so suppose like user one is doing a transactions of 500, then again user one is doing a transaction of 1000, and similar way within 5 minutes, yeah, it is he is doing the maximum transactions of some maximum limit of 5. Okay, so if this will occur, then this comes under the fraud. Okay, if you are setting like, so if transaction is greater than 5 in 2 minutes, so we need to flag the fraud. So might be this is the scenario of fraud. Okay, so these types of problem how you are solving with the help of time based window. Okay, so this is the, that's why this pattern is very important for data engineers. Okay, so they use the sliding window, and that basically use the Apache Kafka or Apache Flink. Then we have the real-time analytics problems also. We can solve it by using the sliding window, or we have suppose like a streaming system where we wanted like a count event in last 5 minutes. So these types of problem we can solve it by using the sliding window. Okay. So if you see most of the questions, they will ask like a maximum substring of size k, or longest substring, or minimum window substring, or maximum number of vowel in substring, or longest repeating character replacement. So these types of problem they will ask if you attend the interview for product-based company. Okay, so I have already explained sliding window. We can solve some more problem also on that. Okay, thank you. Thanks for watching.